Hello everyone and welcome back to this online NPTEL certification course on aquatic geochemistry. In the last class we discussed about water instrumentation and chemical analysis, and in this particular lecture we are going to look into water quality parameters, the commonly measured physiochemical parameters. Okay. Now, water quality is a very broad term. Okay, it is broadly used to understand what is the measure of the suitability of water for a particular use based on its selected physical, chemical or biological characteristics. Okay. So, water quality, when I say, we have to say that for what purpose are we going to measure, are we going to use that water, right. So, whether it is for drinking purpose, whether it is for bathing purpose, whether it is for any industrial use, whether it is for any other use such as gardening, car washing or things like that, and whether it is for recreational purpose, whether. So, basically there are multiple uses of water, and based on the use that you have for that water, you are going to see okay, what is the most desirable physical, chemical and biological characteristic it should possess. Okay. For instance, if you are drinking the water, right, if you are drinking water, you would need balanced water. So, balanced means there should not be any taste, any odor, the chemical constituents, okay, such as calcium, magnesium, iron, all other trace elements, they should be such that it is not harmful to your body. Okay. So, if it is in that range, you can drink it, and if it is above a range which is harmful for our body, you have to treat that water. Okay. You have to bring it to a level where it is no more harmful to your body, right. So, and then you have to say okay, now this is our drinkable water. Okay. If you are going to say whether it for bathing and recreational purpose, then whatever is suitable for our ingestion through the skin. So, there are different kinds of ingestion. Ingestion can be direct, that is we are taking in via our mouth, it is going through our organs. That kind of assimilation is ingestion, and assimilation is a direct intake, but there can also be ingestion from the skin, right. So, when water that is there with a lot of pollutants, then it will harm, it will be harmful for your skin also, and from your skin also it can reach into your system through the blood circulation system, and you anyways can suffer. So, even for bathing there is a certain limit, okay, that exposure, as we say, what is your exposure duration, and based on that a certain limit is it is calculated, and if the water meets that limit, then you say okay, this water is of bathing quality, yes or no. Okay. Industrial, for industrial purpose if they are using it just as a coolant, then there need not be any desirable chemical limit. Okay. It can just be simple sediment free water. It should not harm the people working in that industry. So, if you just meet those characteristics, okay, then that water is suitable to be used as a coolant or whatever purpose that is being used in the industry. Now, when we say these characteristics, we have different parameters. The first things that we measure is the physical parameters. Physical parameters, what are they? Physical parameters, as you obviously you would be understanding, are of physical nature. Okay. That means temperature, that means the pH, that means the salinity, dissolved oxygen concentration, electrical conductivity EC. Okay. EC stands for electrical conductivity. Then ORP, okay. ORP stands for oxidation reduction potential. Then there is TDS. TDS is the total dissolved solids. TSS, that is total suspended solids. And then there is BOD, that is biological oxygen demand. Okay. And then there is chemical oxygen demand. Okay. So, when we are measuring the physical parameters, these are very commonly measured. Always we try to measure at least few parameters. Some basic parameters we definitely measure, such as temperature, pH, dissolved oxygen is a must for all types of samples. This gives us a first hand information of what kind of water you are looking in. Okay. Then for chemical analysis, okay, the chemical parameters, the first thing that we are going to measure is the major ions. Major ions meaning major cations and major anions. As I have already discussed, the major cations is calcium, magnesium, sodium, potassium, and major anions will be chloride, bicarbonate, fluoride, then there will be sulphate, nitrate, phosphate. So, what kind of water you are having, just with the major cation and anion analysis you will be able to tell it whether it is a fresh water, whether it is saline water. Some idea you will definitely get from the major anion analysis. Then trace elements, okay. The next thing important will be trace elements. So, certain metals that you are interested in particularly, or the entire array of trace elements that we have already discussed in the periodic table. Okay. Then there will be organic matter. Okay. Organic matter is it can be in the form of dissolved organic matter or a particulate organic matter. What is organic matter? In natural aquatic systems we have life, there will be plants, there will be bacteria starting from the single cellular bacteria, algae, a lot of plants, lot of animals. So, they will die, they will decay. In that process a lot of organic acids will be released, okay. A lot of carbohydrates, different types of sugars, different types of proteins, all there all that will be there in the water. So, that is our organic matter, okay. Then there can be isotope analysis, okay. Isotope analysis, as I have said, isotopes are used as tracers to understand particular processes, or sometimes as for dating we use, okay. So, different kinds of isotope systems have different kinds of application, and based on your research you are going to choose an isotope system and you are going to apply it. Biological parameters. So, presence of coliform, okay. What is coliform? We are going to talk in this lecture. So, coliforms, macrophytes. Macrophytes are larger aquatic plants. Microorganisms, the type of bacteria, okay, that is there in the water, those analysis are done. Microbial EPS. EPS is a type of substance, okay, exopolymeric substance that the organisms they give out, the microbes they give out, okay. And EPS certain times it attracts certain elements, okay. It can attract trace elements, mostly some trace elements will be attached to this extra polymeric substances that is released by the bacteria, okay. Now, just to understand how it is metabolic some analysis, if your research is related to some metabolism related analysis, then you will do microbial EPS. If it is related to trace element characterization, you can do microbial EPS analysis. Aquatic flora and fauna, the entire array of aquatic flora and fauna, you can take a note of it to understand how the species, how many species are there, what is the species count, the richness. So, all kinds of analysis will be there to assess whether the water is supporting, how much life supporting that water is. Okay. And we have talked about emerging contaminants quite a lot in the first 3 lectures, and there I have mentioned that every water body now is subjected to pollution because of this wide presence of new chemicals. Okay. It can be there in the atmosphere, it can be coming from the soil, so it can be coming from directly from us. Okay. So, somehow it is getting cycled in the environment. Okay. So, what are the types? It can be pharmaceuticals, okay. It can be personal care products, okay. Simple products like oil, shampoos, soaps, detergents, people are using a variety of compounds nowadays, and their utilization has grown multiple times as the years are passing. So, maybe 50 years back there must not have been as many types of shampoos that we find today, as many types of different perfumes and different types of chemicals that we are using on a regular basis. That was not there a few decades ago. So, they obviously from us, since we are using it, we are transferring it to the environment either directly or indirectly. Okay. So, certain compounds are there when we are using it, it can just be volatile, it can be in the air, it can remain in the air for a few days. Okay. And during that time, if it is getting transferred into the soil, into the water, therefore, it is mixing up with the environment. Okay. And how persistent they are. Okay. If they are breaking down very quickly, okay, if they break down to its fundamental constituents, then that is okay. But if it is persistent for more than 5-6 days, then it will definitely enter the water system, the soil. From the soil it will again, it can get leached to the water. Okay. So, there is a different pathways can leach all this type of newly emerging contaminants to aquatic systems. Petrochemicals, okay. New chemicals, by this term new chemicals I mean an entire array of chemicals, starting from pesticides, starting from different kinds of fertilizers, different kind of industrial reagents that they are using, dyes that is used in the textile industry. Dye problem is a big problem, we are using textile industry is huge, our consumption of textile has increased many folds. So, dyes are a very increasingly becoming a hazardous component in the and is being treated as an emerging contaminant, because now it is just their persistence and their nature is becoming different. So, we are considering it as a contaminant. AMR is antimicrobial resistance, and that is of paramount importance. Okay. You see, when you are sick, what will the doctor give you? If you are having a bacterial infection, if you have some viral infection, very commonly you will take an antibiotic, right. Now, when you are taking an antibiotic, that particular medicine will attack the virus that has causing your sickness, but the entire medicine might not get assimilated in our system. So, through our waste system, certain certain residues of that medicine may get released, or there might be a mutation, okay, a gene mutation that can happen. So, what will happen is when the gene, the virus, if that virus gets mutated due to the selection process, that okay, so we are taking a medicine, there was only one particular virus that got mutated, now no longer it responses to that particular medicine. So, it generates a resistance, right. So, that particular virus, if that gets released to the environment, it will take it will take no time in invading all other systems. It will proliferate, it will multiply. Very soon you will have a new I would say population of virus, which will no longer be sensitive to the disease, to the medicine that you have created, right. So, then what will happen, you have to now develop a new medicine. So, that is what is called antimicrobial resistance. That means the microbes, they very quickly they will adapt, okay, or they will mutate, and they will become resistant to the medicines. Okay, how dangerous is it? Okay. Now, you see in our consuming nature, for our consuming nature, antibiotics consumption and usage is extremely high. Any nowadays you will see it is very common, every household they will have some antibiotics in their stock, even if nobody is sick, little some person gets a fever or something else happens, quickly they will give, even if you are not consulting a doctor, they will take the medicine. What will happen is, even that sickness does not need the medicine, you will slowly start releasing that medicine back into the environment through your waste system, right. It will pass out through your waste system, and when it is discharged into the local river or local lake, wherever your effluent discharge is happening, it will quickly populate, and that entire area it can spread out, right. Same thing when this is happening not only to humans, animals are also they are fed with a lot of antibiotics, starting from poultry to cows, then to the meeting, wherever there is meat houses and all. So, they are fed to the cattle, they are fed to all the animals that we are consuming, such that they do not fall sick, okay, there is no virus attack, okay. So, they are given it as a safety, as a precautionary thing. What is happening? Due to their continuous consumption, there is also continuously viruses being created which are resistant to that particular medicine, right. So, every time we are seeing that some new virus will come for whom our medicines are no longer functioning. We have to now develop a new medicines, just like how it happened during the COVID, okay, during the coronavirus, we had no medicine, right. We had to absolutely create new vaccines, new medicines to tackle that COVID problem, okay. So, that whether it is it can happen more in future because of such threats from high medicine use, high antibiotic use, okay. So, now we are many environmentalists, they have cautioned the medical bodies that please kindly start regulating your antibiotic usage, because we can see its impact on the environment. It is not only human lives that is for your safeguarding, it is the entire environment that has to be safeguarded from all kinds of attack and infections and all. So, it is extremely important that we try to reduce our antimicrobial resistant kind of developing that resistance. If you are putting it continuously into the system, those genes, there will be more mutations, there will be more their linkages with other pollutants is also not very well known, okay. So that we have to increase our vigilance with our usage of antibiotic medicines, and for not only humans, to all kinds of other animals as well. Okay. So, as I was telling, so all these parameters we are going to measure, and then we are going to determine what is the water quality. And as I said, based on the use we have, we are going to say whether it is fit for human consumption, or whether it is fit for industrial use, whether it is fit for domestic use, or it is fit for the general environmental water quality, right. Now, for every type of quality, there is a agency that determines this, right. So, there can be WHO, okay, that is the World Health Organization, who says that okay, these are the values which which is the limit, which is the permissible limit for this quality of water, whether it is drinking water, whether it is for domestic water. So, environmental water quality means that water which in which all kinds of the natural habitat can sustain, the natural flora of the system. Suppose there is a lake, okay, whatever is the natural aquatic life that can sustain, that will be the water quality, okay, is required, okay, for that healthy system, for maintenance of that particular healthy lake system, certain values will be set. Okay. So, for India we have the Bureau of Indian Standard, BIS, and they will certify what will be the standard values, what will be the limits for the permissible limit. Okay. Now, what is extremely important is that we follow all the norms when we are trying to do our comparison. Okay. That means, say for instance, whether you are filtering the sample, how you are analyzing the data, okay, what sample preparation techniques you are using. You need to be cognizant about all of that. You need to be cognizant about all the international norms, all the national norms, and you need to set your method accordingly. For instance, it is normal to just filter the water, okay, through that 0.22 PES membrane and then measure it for trace element analysis. But many times it is seen that some researchers, they will digest the sample. Digest means they will completely evaporate the water, or they will do acid digestion of the sample. So, different kinds of sample preparation methods they will come up. But what will happen in that process is they are going to add some contaminants, or through the acids it can come, or so basically you are not following the norms with which your other data in the literature is there. Okay. So, when you are comparing your values, you will see that there is a difference, either it is higher or lower the values are. Okay. And then you will find okay, the methods were different, right, due to the methodology that was taken, due to the instrumentation also. Sometimes there is different sensitive instruments, there are some instruments which are not as sensitive. So, the reporting values are very different, right. So, you have to be remembering that we have to follow the international and national norms for measurements, right. And then there is something called the drinking water quality. So, whatever when our BIS gives us water quality parameters, they generally mean the drinking water quality parameters, right. So, for them you will see different kinds of values are there, right. So, for every element there will be a different value. So, for chromium it is 50 microgram per liter, cadmium 3 microgram per liter, lead 10 microgram per liter. That is the upper limit. Okay. If the values are higher than these values, you can no longer say it is fit for drinking. Okay. but you compare now this with a different place. Okay. For example, these values is from this agency, okay, Australia and New Zealand Ecological Conservation Committee, and they have given the maximum acceptable toxicant concentration for long term exposure of for aquatic life. That means certain, they are very stringent about their preserving their aquatic life. For them, their value is not the limit for drinking water, they want a healthy ecosystem, right. So, this ANZ-ECC, they have reported different values, that means the maximum acceptable toxicant, so this is a toxicant, that means these are all toxic metals, right, chromium, cadmium, lead, they are all toxic metals, they are all carcinogenic in nature, and therefore, not only for humans, for aquatic life also they are considered toxic. So, they are toxic nature. If your lake, the aquatic life, they have a long term exposure, they are living their entire life there. So, for long term exposure, what is the limit? Okay. What is the maximum concentration that can happen? For them, the limit is, as you can see, is obviously way lower, it is 50 times lower. Chromium is reported, cadmium, here we have 3 microgram per liter, here it is 0.2 microgram per liter. For lead, it is 3.4 microgram per liter. So, that different, therefore, we just try to understand the different water purpose will have different units. Okay. So, with this we will see some physiochemical parameters that we are going to commonly measure. The first one is temperature. Now, what is temperature? Temperature is how hot or how cold that water is, right. And this is extremely important. Why? Because aquatic life has got a limit that up to which it can sustain itself. Okay. So, fishes, insects, different types of algae, they are sensitive to water temperature. Okay. And they, if the water gets very hot or it gets very cold, then they will move out of that entire system. So, aquatic life, okay, temperature controls the aquatic life in water. Okay. If it is getting very hot, if it is getting very cold, both can be detrimental. So, aquatic life, they are evolved with that with that particular water system. So, maintaining that temperature is extremely important. Sometimes due to human interventions, the temperature gets changed. Okay. Say suppose you are to a mountain river, you are adding some industry is there. Okay. And then that industry, due to use water as a cooling agent and all that, so that water that is coming is slightly having a warmer temperature, and when that water, which is whose discharge value will be quite higher, is mixing with the local stream, then the temperature whatever was there can get altered. That alteration give rise to a lot of complications in the food web, in the in the aquatic life. Now, naturally there is a temperature cycle, and this is especially this cycle that you are seeing in this figure, that is seasonal cycle, is very common in the temperate regions. So, in the temperate regions we have very clear cut summer season, so summer season, then there will be in India there is rainy season, in other places there will be autumn, there will be winter, then there will be spring season. So, in enclosed water bodies, okay, such as lakes, the temperature will change with this season. Okay. And due to the stratification that we commonly observe in lakes, this is a seasonal phenomena, as we say. So, for instance, in the summer what will happen? There will be warm water on the surface, okay, at the air and the water interface, there will be warm water, and cold water will be there at the below. Okay. Then what will happen in the fall season, okay, that is in the autumn season, what will happen? This surface layer will slowly start becoming cooler and cooler. So, due to it becoming cooler, it will start sinking and it will start mixing, okay, it will start getting mixed with the bottom layers, and there will be a autumn mix. Okay. Then again comes more cooler temperatures, and there can be generation of ice on the surface. So, what will happen is at the topmost layer it will get frozen. Okay. After it gets frozen, there will be no more heat exchange, water will remain at 4 degree Celsius. After that, again it will start as spring comes, it will start melting again. So, you have now here more slowly it will some warm, the surface layer will start getting warmed, and then again the cooler layer, whatever is cool water will start falling, moving downwards, and all the warm water will start moving upwards, and again it will move towards a final stratification, right, until and unless the entire top layer gets completely warm and the stratification is stable. Okay. So, this is a seasonal phenomena and it is very commonly seen in lakes. Okay. Now, why is so important? As I have already said, it is very important because it determines the plants and animals that can live. Okay. Temperature therefore determines the amount of dissolved oxygen in the water, because colder water can hold more oxygen than the warm water. Okay. So, how much dissolved oxygen is there? That is extremely influenced by this temperature. Then smaller systems, they are more susceptible to temperature change than larger systems. Okay. So, small lakes, small streams, okay, they are more sensitive to temperature change as compared to larger lakes, larger rivers. Okay. And that means that during the low flow periods, okay, that means during the higher, if you are considering a lake, then during the summer the temperature sensitivity will be maximum. Okay. It can very soon dry up and the oxygen concentration will be very low. So, a little change in from a little stress can trigger a lot of changes. So, smaller water bodies, they are more susceptible to temperature related changes, and climate change that definitely affects the water temperature, and a lot of times we have seen that fishes, they shift their habitat, and sometimes they are found in different regions, because you will come to know, okay, the water temperature has changed and therefore they are laying eggs and all that. So, a lot of things related to aquatic life gets changed because of temperature. With this I will come end to this lecture, and I will continue to discuss more about the physiochemical parameters in the next lecture. Thank you.